Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandar. Students, in this power systems through topic wise MCQs, we have completed 4 sessions. Okay, it is the fifth one. In this session, we are going to learn the topic transmission and distribution based questions. Okay, so let us start the session, guys, and don't skip in the middle. Try to watch complete video. Okay, you will get a very good questions. Okay, very repeated questions. And if you want download the PDF, you can download from sunelengineeringacademy.com. Okay, let us start. The questions belongs to transmission and distribution. Okay, so coming to the first question, the length of short transmission lines is up to about dash. We know the classification. This is the very basic question. Okay. So what is the classification we have? Whenever the length of the transmission line is less than 80 kilometers, we can say those are short transmission lines. Length is between 80 to 160 kilometer. Then we can say that is the medium transmission line. Whenever the length is greater than 160 kilometer, then we can say that is the long transmission line. Okay, so they have given short transmission lines up to 80 kilometers. So answer is option A. Very easy question. All these classification valid. This is the very important. Okay, here the key point you have to learn. All this classification valid for power frequency. Valid for power frequency only. What is the power frequency? Frequency is 50 hertz. If the frequency is greater than 50 hertz, this classification is not valid. Okay. Okay. Coming to the second question. Which of the following is not a standard transmission voltage? We know what are the standard transmission voltages. 11 kilovolt, 33 kilovolt, after that 66 kilowatt, after that double of that 132 kilovolts. Okay, so all these are nothing but you can say 220 kilovolts, 765 kilovolts. Okay, so all these are nothing but you can say standard transmission line voltages. Here 99 is not there, so we can give the answer as option B. 99 kilovolt is not a standard transmission line voltage. Okay, coming to the next question. A transmission line of 50 kilometer length is operating at 500 hertz. It can be classified as dash. I have already given the classification, this classification valid for 50 kilohertz only. If this frequency is greater than 50 hertz or not 50 hertz, then we need to calculate frequency into length. Frequency into length. Okay, so here also we need to calculate frequency into length. If it is less than 4000, then you can say it is the short transmission line. If the frequency into length is 4000 to between 4000 to 10,000, 10,000, then it is the medium transmission line. Medium transmission line. Okay, so whenever the frequency into length is greater than 10,000, is the long transmission lines. Okay, so here we need to calculate frequency into length. What is the value you get? Frequency 500, here 50. So that means 25,000. 25,000. Okay, kilometer hertz. So here 25,000 means greater than 10,000. So simply we can say it is the long transmission line. So long length line. All of you clear? So sometimes they will give this logic. If they have not mentioned frequency, then you can simply say it is the short length line or short transmission line, correct? So don't confuse, guys. Whenever they have given the frequencies other than 50, calculate f into length. Okay, I think all of you got. If you got it, click on like button. Then only I can get idea you are getting my concepts. Okay, and you can also give the comment. Identify a valid disadvantage of HVDC transmission line. You know very well, high voltage DC transmission line. So if you are using the AC transmission line for very high power, then we will get the more losses. Okay, so more losses are introduced in the system. So to reduce that, we are going to use the HVDC. Here in the HVDC, how we are transmitting? Here, whatever the voltage at generating side, we need to convert AC to DC converter. And we are transmitting DC by using just a two-wire system. Okay, two-wire, a positive and negative. So we can reduce the conductor size, and as the conductor size reduces, losses are also reduces. And at receiving end, at load end, again we can convert DC to AC. So this is the process, I think you know very well. In this, what is the disadvantage we have here? This AC to DC or DC to AC converters. So this power electronic devices, this converters cost is high. So we need to place this. So this is the disadvantage, expensive converter. So the answer is option A. Okay, in the HVDC we don't have skin effect, correct? We don't have radio interface also. We don't have corona losses also, as the frequency is 0. Corona losses are also 0, correct? Okay, not 0. Corona losses are reduced. So why? Because the corona loss is proportional to f plus 25, I think. Okay, so as the frequency is 0, corona loss may be reduces. Okay, so the disadvantage is expensive conductors, converters. Coming to the next one, the minimum clearance distance that equipped should be kept away from 50 kilovolt power line is dash. This type of questions are very important for your JEE examinations. Okay, so I will give some data about this. What is the minimum clearance required for particular voltages? Here let us take the particular voltage, the minimum clearance. Okay, so here I am giving in the feet. Okay, so they will also give in the feet, but they have not mentioned. Okay, so if up to 50 kV, up to 50 kilovolt, the minimum required is 10. Okay, if it is 50 to 200 kilovolts, then 15 is required. 200 to up to 350 kilovolts, this is the 20. So generally if we use 220, they are asking, then what is the, you will give the answer 20 kilovolts. Okay, sorry, 20 feet. For this 20 feet, you need to give the answer. Okay, so if they have given that is 350 to 500 kilovolts, the clearance required is 25 feet. Greater than 500 or 500 to 750 kilovolts. Okay, so 35, 750 to 1000. So generally we go with the 765. So for that minimum required is 45 feet. So over than 1000 kilovolt, at least 50 feet is required. Okay, 50 feet is required. So here the minimum clearance should be kept away from 50 kilovolts. 50 to 20, there is the 15. Up to 20, up to 50, 10 is given. So the answer is 10. For up to 50 kilovolts, we can go with the 10 feet distance. That is enough. So the answer is option B. Okay, all of you clear? A very simple thing. So try to remember the data. Try to remember the data. Coming to the next question. Performance of short transmission line can be obtained by dash. Here the performance of short transmission or medium or long, whatever it may be, we have some methods to get the what is the regulation. Okay, the main performance is nothing but we need to find out the regulation, that is voltage drops and all this. So here, in case of short transmission line, less than 80 kilometers now, in that very less means capacitance effect is neglected. Okay, so here we can neglect the capacitance effect. So, and the parameters are also within the range. So that's why you can go with the lumped model. Lumped model. So directly you can take the values, resistance, inductance values. But whenever, if you can consider that is short transmission lines, we can go with lumped. In case of medium transmission lines, length is very high now, so we need to calculate them in the distributed parameters. Distributed manner. Distributed in the sense inductance per kilometer, capacitance per kilometer, resistance per kilometer. We need to take the calculations like this. Okay, so distributed way. So in this medium transmission lines and also long transmission lines, in both we are going with distributed. Okay, so here in case of medium transmission lines, we go with the nominal T and nominal pi methods. Long transmission lines, we go with the equivalent T, equivalent pi methods. So nominal T and nominal pi is for medium. Very important, guys. Equivalent T or equivalent pi, this is for long transmission line. Okay, so the answer is option D here. And sometimes they will give a question like in which transmission line capacitance effect is neglected, that is in case of short transmission line. Okay, length is very less, so the capacitance effect we can neglect it. As the length is more, capacitance also more, correct? Capacitance also more, so we, as the length increases, the earth effect is increases, capacitances are added in the parallel. Okay, so the capacitance value increases. Medium transmission line they are asking, so I have already given nominal T or nominal pi method for medium transmission lines. Long transmission lines already given equivalent T or equivalent pi method. Equivalent T model is quite suitable for analyzing the performance of transmission line. Indirectly they have given equivalent T or equivalent pi method, we can go with the long transmission lines, correct? Long transmission lines are nothing but greater than, length is greater than 160 kilometer. So it is a combination of two questions. Greater than 160 kilometers, they have given only one option, 250. All of you getting a very simple question and very beautiful question. Correct. Coming to the next question. In case of nominal T representation, the medium length transmission lines, the shunt capacitance will be dash. So in case of nominal T or nominal pi methods, we are going to use in which transmission lines? Medium. So they have mentioned that the question itself, we have one answer. Nominal T methods are used in the medium transmission lines. So coming to this T method, nominal T method, as the letter itself T, so it is in the manner of T only. Okay, T type. So this is the T type now. This is the T type. So here we are going to use this nominal T method. Here we have the impedance, that is like half of the resistance, half of the inductance, R by 2, X by 2. So here also same. R by 2, X by 2. And here we are taking the total capacitance. So this is the, if we give the supply here, and here we are going to give the load. Okay, so this is the nominal T method. So here shunt capacitance, where we are going to take at the middle, assumed to be at the middle. Okay, assumed to be lumped at the middle of the line. Lumped at the middle of the line. Okay, so the answer is option D we have. Answer is option D. Okay, all of you clear? A very easy question. If they have given nominal pi method, nominal pi method. Okay, so in case of nominal pi method, so pi manner. Okay, nominal pi manner. Just wait. Okay, you know very well the pi. This is the pi. Okay, so here resistance, inductance. Here we have one branch. Here we have one branch. Now it is like looks like a pi. Correct. So here we are going to take total resistance and reactance. Here capacitance is divided at a starting. That means supply side and half of the capacitance at load side. Okay, half of the capacitance at load side. So here in case of nominal pi method, it is equally lumped at each end of the line. Equally lumped at each end of the line. So that is in the nominal pi method. Okay, all of you clear? Coming to the next question. Voltage drop is the main consideration while designing a dash. So in case of distribution lines are divided into distributors and feeders. Okay, so here voltage drop is the main consideration in case of distributor. Here based upon the voltage drops we are going to design this. And what about the feeder? Feeder case we are going to maintain the constant current or constant current density. Okay, so it is current phenomena, current carrying capacity. Current carrying capacity or current density. Okay, so in the distributor, the main phenomena is voltage drop. In case of feeder, tappings are not allowed, and that means we may not connect any loads for this. Tapping not allowed. Okay, not connected any loads. Any loads. Whenever the loads are not connected, then you can say we have to maintain the constant current density, current per unit area. Constant current density, current per unit area. So we have to maintain constant. Okay, so that means depends upon current carrying capacity. Here in the distributor, we have to take the tappings. Okay, so whenever here that is some amount of current is flowing through this, then there is some voltage drop takes place. Some voltage drop takes place. Okay, so if you send 240 volts at the starting, so in the last in that street, the person or the house which is available in the end may be getting 210 volts, 200 volts, like that, if there is a more houses. If there is the more houses, 3 4, these are nothing we can say loads. Okay, so that means they must give at least more than 220 kilovolt, 220 volts, then only all the loads are working fine. So based upon that voltage drop, how much voltage is dropping to the end, based upon that they design the distributor. Okay, this always feeder is connected to distributor, distributor is connected to service main, like that. Okay, okay, so I'm giving in the other one. Coming to the next question, current carrying capacity main consideration in case of feeder. So feeder is connected to distributor. Okay, I have already given a feeder is connected to distributor. In which of the following transmission line capacitance effect is neglected? This one also have given. In case of short transmission line, the capacitance effect is neglected. Okay, coming to the next question. Here maximum regulation, minimum or zero regulations based questions we have. What are the conditions? Here whenever the pi is equal to theta or theta is equal to pi, pi is equal to theta or theta is equal to pi. So what are these? We know very well theta is nothing but impedance angle and pi is nothing but power factor angle. Whenever both are equal, then we will get maximum regulation. We will get maximum regulation. Whenever sum of those two is 90 degrees, theta plus pi is equal to 90 degrees, then we can get zero regulation. There is no need of any regulation or zero regulation. So the answer is option C. These are the two conditions we have. Okay. Now coming to the next question. In a short transmission line, resistance and inductance are found to be equal and regulation appears to be zero. Then the load will be dash. The load will be dash. For this type of question, most of the students focusing on resistance, inductance are found equal and what is the regulation appears to be like that. Okay, so focusing on this point, no need of focusing of that point. Focus on this point. Regulation appears to be zero. If you take power systems, synchronous machine, transmission, the transformers, any one, the regulation curve is almost the same. We know this is the regulation curve. Correct? Here unity power factor. After that, here we can say lagging. Here we can say leading power factor. Okay. At unity power factor also, the regulation is not zero. So the regulation is not zero. Where it is zero? Here. That means at a leading power factor, the regulation we can get minimum or zero. So and very near to unity power factor. Okay, very near to unity power factor. So the regulation is zero in case of only leading power factor. Only one option we have. So directly we can go with option C. All of you clear? No need of any calculation. Here their meaning, the examiner meaning is this only. All of you getting a very easy question na? Okay, if we know the answer, then it is very easy question. If we don't know the answer, it is not a easy question. Correct? So if you like my concept, don't forget click on like button. Okay, you may forget at the end, so that's why click now only. Okay, yes. Coming to the next question. So keep in mind, whatever the data they have given, we want to look where we can get the answer. Okay. Next question. Here they have given regulation in percentage. Regulation is percentage. We know very well the regulation formula. All of you try to remember. Percentage R cos pi at receiving end plus percentage X sin pi of at receiving end. Okay. R cos pi plus sin pi. Cos pi plus sin pi. Until unless they have given, we have to take this is the for lagging power factor. Okay, for leading power factor, we know very well there is a chance of zero or negative. Okay, 0 or negative is possible only in case of minus, correct? Only in case of minus, then only there is a negative or 0 possible. Here there is no chance of 0, correct? So that is the simple thing to remember. Okay, that is the trick to remember. So plus, maybe maximum you will get, maximum regulation you will get. There is a chance of minimum or 0 in case of minus only. So minus for leading, plus for lagging. Okay, so until unless they have mentioned anything, we go with the lagging only. So substitute the values percentage R. So resistance percentage R per unit, both are same. 2 per unit, cos pi is 0.8 given, plus percentage X reactance is nothing but can say percentage X or X per unit, percentage R per unit. Okay, plus percentage X is 3. If the cos pi is 0.8, sin pi is the 0.6. I think all of you know very well. The cos pi is 0.8, then sin pi is 0.6. If the sin pi is 0.6, cos pi is 0.8. Okay, so reverse. That is the reverse. Okay, so calculate this one. 1.6 plus 1.8, that is 3.4. 3.4. So what is the answer now? 3.4. So answer is option B. Okay, coming to the next question. With the short line R by X is ratio is 1, the regulation will be 0. Again, same type of question. Regulation is 0 possible whenever it is the load is leading power factor and near to UPF. Okay, so here not unity, not lag, so there is a chance of these two. So in this also not 0 power factor, correct? Near to unity power factor, that is, so only one option we have. So the answer is option 0.707 reading. Okay, as per I rules, the permissible variation of voltage at consumer end. So what is the permissible voltage variation? That is 6%. 6%. Okay, so frequency, if you consider the frequency variation, 3%. Okay, yes, here they have given as per I rules frequency variation 3%. If you can consider grid, at grid is very less. If they are asking at a grid, the frequency percentage is less than, frequency variation may be less than 1%. Okay. The dimensions of constants B and C are dash. What are these B and C? If you take a transmission line parameters, I don't know how you are watching the session. Okay, so I want to give the idea how to watch the MCQ session. First of all, whenever I have given the question, pause the video. Okay, and try to think your answer and how much time you have taken for that. Okay, for theory question, how much time, and that is numerical question, how much time you have taken. After that, check with my answer. Okay, so that is the way to practice the MCQs. Okay, just listening the MCQs means you may not get a clear things. Okay, so transmission line parameters, you know very well. VS is just listening means you feel bored. Okay, so if you try yourself, after that check with my answer, then it will be more interesting. So try to make bore to interesting. Okay, getting my point. We know transmission line parameters, sending end voltage and sending end current. Vs is equal to AVR plus BIR. Here CVR plus D. Okay, they are asking about this B and this C. If you want to get the B, make A as 0, or it is very difficult to make the parameters as 0. So only you can make a VR or IS 0. Okay. So if you make a short circuit, voltage will be 0. If you make open circuit, current will be 0. So let us take VR is equal to 0. Then what you will get? Vs is equal to BIR. From this one, B is equal to voltage by current. Voltage by current is resistance. Resistance means ohms, na? Ohms. Ohms. We have two options are there. So no, you need to calculate this one also. Here, if you want to get the C, make IR as 0. So then IS is equal to CVR. Then C is equal to IS by VR. So current by voltage. Current by voltage. So that is nothing but conductance. Conductance mho or Siemens. Okay, so ohm and mho. So answer is option A. All of you clear? Okay. And these parameters, we have one more concept is there. Whenever this AD minus BC is equal to 1, then you can say it is a passive network. Passive network. And whenever A is equal to D, we can say that is the symmetrical network. These 2 points are very important for our exam. Okay. So all of you know the transmission line parameters. Okay. So ohm and mho. Here AD minus BC is equal to, generally you can take 1. Why? Because it is considered as always passive network. So AD minus BC is equal to 1. Condition for symmetry, I have already given A is equal to D. So the answer is option A. The nature of line constant in rigorous solution. Rigorous solution is method to find out the performance of long transmission lines. We have the two methods, rigorous method and also equivalent T equivalent pi. Okay, so two methods we have, equivalent T and equivalent pi are rigorous solution. So these are used to know the performance of long transmission lines. In case of long transmission lines, we go with always distributed parameters. I have already given. So distributed parameters, so the answer is option A. Okay, and coming to the ring main systems. Ring main distribution is preferred to a radial system because in case of ring, so we have connected the transformers or transmission lines in the distribution, whatever it may be, if you can consider. So here they have given distribution. So in the distribution, we are using the transformer. So those are connected in the ring manner. So here we have connected like this. Okay, so for example, here we have one customer is there, one load is there. So is there any failure of this transformer? He can get the supply from this transformer. If it is failed, he get from this one, if it is good. Okay, so that means there is a more reliable connection, more reliable. Okay, more reliable. So voltage here supply is more reliable. And what about the voltage drops? For example, if you can consider a system, if we have a transformer here and here we have the load is there. If there is a lot of distance, then there is a voltage drop will be more. Voltage drop is more. Okay, so to reduce that voltage drop, if we have any other transformer very near to this house, then we can reduce the voltage drop. So voltage drop in the feeder is less whenever we go with the like this ring system. Okay, so voltage drop is less and supply is more reliable. Coming to the next question. The size of neutral wire as compared to that of line wire should be in case of single phase supply. In case of single phase supply, we have the phase and we have the neutral. Okay, so here whatever the supply you are sending, that will be returned back through the neutral wire. Correct? So that means whatever the current flowing in the phase, the same current is flowing in the neutral. So whenever the currents are same, then we need to take same area of the conductor. Okay, area of current is depend upon area of the conductor. Okay, so current same means we have to take same area, that means equal size. In case of three-phase, then you can take a neutral wire is less than that of the phase wire. Why? Because in case of three-phase system, generally no current is flowing through the neutral. But whenever there is a abnormality, then only there is a current flow through the neutral. Correct? So that's why the neutral size may be less in the three-phase system. But in single-phase system, must be same. Okay. A conductor carries more current on the surface as compared to core. This is called as test. This is nothing but skin effect. I think all of you know very well. What is the nature of alternating current? So the nature of alternating current, it is always flows on the top of the or surface of the conductor. Always trying to flow on the surface of the conductor. Okay, not trying to go in the total. So this is nothing but you can say skin effect. Due to this, what is happening? So the effective area of the conductor is reduces. As the effective area of the conductor is reduces, the current carrying capacity is less. Why? Because as the area is less, R is equal to rho L by A. Okay, as the area is less, resistance will be more resistance. So more resistance means we may get the losses. Loss will be increases. Okay, that effect is nothing but we can say skin effect. That means here whenever this conductor size is very less, so whenever we are going to use less area of the conductor, okay, diameter is less. Whenever the diameter is less, then already the diameter is less, so if it is trying to flow in the surface also, it covers the total area. So it covers the total area means effective area, utilized area is more, then resistance will be less. So we can reduce the skin effect. So that's why we are going to use, instead of solid, we are going to use a stranded. So in the stranded conductors, we are going to take a small area of the conductor, very small leads, and twisting all them together to form a single conductor. Okay, so if you observe our domestic wiring, so many small area of the conductors are wires twisted together to form a single. Okay, to reduce the corona losses. Okay, sorry, to reduce the skin effect. Okay, reduce the skin effect. So skin effect is nothing but the alternating quantity of the current is always trying to flow in the surface, so are crowded at the surface of the conductor. So due to that, effective area is less, resistance is more, so we may have the losses. Okay, what is the proximity effect? Proximity effect means we have the two conductors are parallel to each other. Due to one conductor, there is a other current conductor is using almost half of the effective area. So as the area is less, resistance again more. So again we are getting the losses. So these two effects we have. Due to that, resistance will be increases. A very important question. So in the AC, resistance is more. Why? Because due to both skin effect and proximity effect. Okay. Coming to the next question. Here skin effect depends on dash. Skin effect is depends on dash. The skin effect is depends upon first one, nature of material. Okay, and the second one, frequency. As the frequency increases, skin effect is more. Okay, so alternating nature increases now, so skin effect is more. And third one, diameter. As the diameter is more, skin effect is more. Okay, simple idea, guys. For example, we have a 40 feet road. 40 feet road. Okay, so or let us take 40 feet or 80 feet road. Let us take 80 feet road. So in this case, we may have a divider is there, correct? We may use the divider. Here may be 3 lines. Here may be 3 lines. Okay. Okay. So here the vehicles are trying to move very left side here and here. So most of the place is not utilized. Most of the place is not at all utilized. Okay. So the effective area, utilized area is less here. If you can consider the same in case of just a 4 feet road, just a 4 feet road. So in this case, okay, so vehicles only one way direction, correct? Let us make a 6 feet or 8 feet or at least 10 feet. If you take a 10 feet road, if one car is moving, there is no other vehicle can move, correct? So almost it covers almost all the area. Okay, if one lorry goes, then it covers all the total area, correct? So there is no wasted area here. So effective or utilized area will be more. Utilized area will be more. So whenever the utilized area will be more in the sense, then we can get the less losses. Okay. So depends upon all these three. So we can go with the option is answer is option. If the frequency increases, skin effect already have given. If the frequency increases, skin effect is increases. Okay. Coming to the next one. If the diameter increases, skin effect also increases. Okay. Diameter increases. Then effective area is reduces. So resistance is more and skin effect also. Coming to the next one. DC resistance of a conductor is less than the AC resistance. Why? Because both this effect. So we can give the answer is options. Okay. Answer is options. The economic size of the conductor is determined by Kelvin's law. I think all of you know very well about this. Okay. All of you know very well about this. A small brief idea of this. Okay. So if you can consider conductor area, annual cost. Okay. Conductor area, annual cost. So if you can consider the area is more, then conductor cost is more, correct? So as the area is more, conductor cost is more. So we can say annual conductor cost. But as the area is more, then it can carries the more current. It can carries the more current. Correct? It carries the more current. Okay. And what about the energy losses? Energy losses. For the same, if the area is more, R is equal to rho L by A. As the area is more, resistance is less. As resistance is less, losses are reduced. Correct? So as the area is more, the losses will be less. So the losses will be less here. As the area is less, losses will be more. So we can say the curve may be like this. Okay, curve may be like this. So energy losses. Area is less, more losses. Area is more, less losses. All of you clear? So R is equal to rho L by A. So that means based upon the Kelvin's law, it says that we need to take the conductor area and cost and energy losses all in the consideration. If you go with this one, at this point, we may get medium amount of that is medium cost of conductor, and energy losses are also minimum. So that's why we are going to take this much of area and we are going to spend this much of amount. Then we may get that economy. Okay, economy. So the economic size of the conductor is determined by this law, that is nothing but we can say Kelvin's law. Coming to the next question. The overall diameter capital D of stranded conductor stranded conductor is given in terms of diameter of each strand d and number of layers in as dash. This is the direct formula only. The overall diameter of a stranded conductor. I already said we are going to take a number of strands and twisting them together to form a single conductor. I think I have seen a domestical wire. So d is equal to 2n minus 1 into d. Okay, if you open JB Gupta, you have wrong formula. So be careful, guys. 2n minus 1 into d. This is the total diameter. And ACSR conductor. ACSR is nothing but aluminum conductor, steel reinforced. So here we can go with the outer side conductors. Aluminum conductor, steel reinforced. Why we are using steel reinforcement? To get mechanical strength. Mechanical strength. We know very well. The aluminum mechanical strength is not that much, not stiff. Okay, if you go with the steel, it is a high mechanical strength. So that's why we go with the aluminum conductor and steel reinforced. Okay, so this is the conductor. So aluminum is the conductor. Okay, so that means it carries the main current. So here outer conductors are made up of aluminum. Central we have steel rod. From that we are testing all the aluminiums. And finally form the rounded structure. Okay, rounded structure. So outer conductors are aluminum, inner conductors are outer, inner conductor is steel. Okay. In ACSR conductor, the number of strands in third layer. If you can consider in any layer, in case of n layer, the formula is 3n square minus 3n plus 1. So if they are asking third layer, 3 into 3 square minus 3 into 3 plus 1. 9 into 3, 27 minus 9 plus 1. 28 minus 9 means 19. So the answer is option B. Okay. So the number of layers generally in the first layer we have only one conductor. In case of second, from second onwards we are going to use 6, 12 and 18 the fourth. So if they are asking about third layer, we need to calculate these three. Combine these three. 1 plus 6 plus 12, that is equal to 18. If they are asking fourth, then 1 plus 6 plus 12 plus 18, that is sorry, it's the 19. 19 plus 18, 37. 37 is in the fourth. Okay, so like that you can give. And always one more thing, aluminum strands are greater than steel. Aluminum strands are greater than steel. Okay, so aluminum is used as a conductor, steel is just for getting the mechanical strength. Steel has high resistance, so we will get very high losses. Okay, so we may take very less. 7 by 54, the number of aluminum strands. Whatever they have given, less is steel. Steel always less than aluminum. So steel is 7, aluminum is 54. So they are asking about aluminum, so we can give the answer as option B. Okay, a very easy question, guys. A very easy question. Okay, whatever they have given, if they have given 7 by 54 or 54 by 7, whatever it may be, so 54 is belongs to aluminum, 7 is belongs to steel. Okay, students, we will discuss the remaining that is especially inductance and capacitance based questions in the next session. Okay, I'm going to end this one. If you like my class, don't forget click on like button and also give in the comment. Okay, and if you want download the PDF, download from sunilengineeringacademy.com. If you open that one, in the first video you have how to download the PDF, just a 1-minute video, guys. Okay, click on that one and watch that 1-minute video, then you will get the idea how to download the PDF. Okay, students, I'm going to end the session. I love you. Thank you so much for watching. Take care. Bye guys.